The LG Procast is intended for informational and entertainment purposes only. The views or opinions expressed by the podcast hosts and guests do not necessarily reflect the official position of LG. For the latest and most accurate information about LG products, please consult relevant product manuals and related documentation.
Welcome to the LG Procast. I'm Thierry Frisenda.
And I'm Phillip Craigbaum. Thanks for joining us for another episode today. If you guys didn't catch the last episode, we had Alex Meany on here, and we had a great discussion with him, talking about load calculations, building science, system selection. And we wanted to take a few minutes to unpack a little bit further, especially the system selection size. Talk about how to pick the right size system and some of the dangers or pitfalls if you don't. So, Terry, what'd you think? Did you have a good time?
I did, and I love it when I learn stuff, and I learned a lot of stuff from that podcast last episode. And Alex made several comments that resonated with me. The intersection of building science and HVAC. I think that's just a great term, because as the building industry continues to evolve and as envelopes get tighter, we've talked in the past about the challenges and the things that do for the HVAC systems that we put in these homes. As Alex said, building science comes into play there. Do we bring other technologies along with the HVAC system to make a true system that performs in his home in the heating and cooling modes, that gives the consumer, the buyer, a better indoor environment, and something, that he said over and over and over, something that doesn't just make my customers happy, right? Something that, and I want to chime in and say, something that makes my equipment happy, right? Because I think if I have happy equipment, and by that I mean equipment that's sized correctly, installed correctly, right? Doing the things that it's engineered and designed to do, then I think that will lead to customer happiness.
Absolutely. And we're witnessing right now a fairly rapid change in all of that. Buildings are getting much, much, much tighter and more insulated. And, in the last 50 years, we've seen homes that, used to be 100,000 BTUs are now being cooled for 30 and 40,000 BTUs for the same square footage or footprint. But because we've used drastically different building materials, building methods, they're just getting much tighter. And that has to make us think about not only just air conditioning, but it reminds us why there's the letter V in HVAC, right? We're not just here for heating and air conditioning. We're here for heating, air conditioning, and ventilation. And ventilation is becoming more and more important on these tight homes, whether it's foam encapsulation or whether it's zip wall and taped up and sealed up. But we're getting these homes that just have very, very low infiltration rates. And for the health of the occupants, absolutely, we have to start bringing in fresh air. And so that changes a little bit on the size end of the equipment. The low load in the home changes the size of the equipment. Obviously, if there's a lower heat load and heat gain, then obviously we're going to need smaller equipment. And so that's going to change things. So it's a lot going on in that world right now.
Now, if you look at what we do from a manufacturer's standpoint, we make these incredible inverter-driven systems. They have the ability, variable capacity. We touched on that during the last episode. They have the ability to change their output and meet some of these new conditions. But that doesn't make them the wherewithal. Okay, it still requires understanding this building. It still requires understanding this installation and application, so that we're putting the right size evaporators that get the right amount of runtime, that do the things that this equipment can do and engineered to do. And again, I'll use the word happy equipment, to get equipment to run like it should be running, not short cycling, not running its life away, but getting good run cycles out of it. That's the way we're going to make it better. And if you think that comment he made on the last episode really stuck with me, is that, do you bring the system to the house, or do you bring the house to the system? Right? Because that's powerful, right? Guys taking a 3-ton system out, and there's his favorite terminology, right? 3-ton. Guys taking a 3-ton system out and just putting a 3-ton system back. We talked about it on other episodes. That's just not what this industry can continue to do. It it's done every day, we know it, or it's done frequently, and the importance of understanding the load calculation and the equipment performance through the manual S will stop this, right? But we got to get folks to do what? We got to get folks to educate themselves and their companies and better understand this whole process.
Right. And equipment's not what it used to be. And I don't mean that in a negative
True.
connotation. It's
True.
just, it has changed. The sensible to latent ratio of equipment from 25, 35 years ago versus today has changed. And, there's some reasons for that. And some of it is chasing ratings and things like that, where to get a certain SEER rating, we're giving up latent capacity to get better ratings. And so that's obviously that's a piece of it that's driving it. But some of the manufacturers and you've got to look carefully. And I think that's what Alex was getting to when we were talking to him is, if it calls it a 4-ton system, back in the day, that meant you got 48,000 BTUs out of it. Today, that doesn't always mean that. Sometimes you will, sometimes you won't. But what it means is that we have to actually go into the data and make sure that it's going to meet the demand that's required, both the sensible and the latent. And that's why there is the manual S. And I think a lot of guys just kind of glaze over manual S and say, well, I did a load calc. It tells me what I need to know. I'm going to go with the rated capacity on the box, and I'm going to stick that in. And it hasn't given me a whole lot of trouble in the past, so I'm just going to continue to do that. But even with inverters, right? So we have inverter-driven machines that have the ability to ramp up and down. There's a large misconception that you can't really oversize an inverter or a mini split, but if that were really, really true, then there would be a big exception for manual S and say, hey, if you're using a variable capacity machine, you are not subject to manual S anymore. But that's not the case. Manual S is still a requirement by code throughout the whole country, whether it's enforced or not. It's still part of the building code, is that there's a manual S that's done, that's sized appropriately. That's part of the National Electrical Code when it comes to air conditioning and appliances. So manual S is the way that we size them. So we have to understand that, and I know we can't get into how to do a manual S in a short little podcast, right? Because depends what climate you're in and depends what type of equipment that you're using. Obviously, everything that we make is inverter driven, so that falls in the variable capacity sector. But you've got to get into the numbers, right, Terry? So it's important that we just don't look at the box and say, hey, that's a 2-ton, that's a 3-ton, that's a 4-ton. My load count came out to whatever. There's a lot more that goes into those rated capacities than just that. And again, they're rated capacities. So that may change based on where you live and what your climate is. You may not get all that capacity.
Certainly it'll change not only on based off geography, but also change on the installation and application of that product. So we spoke last episode a lot about, man, I can do everything under the world, but if I short cycle or not short cycle, but if I short size the return air and I have a chromie duct system, I don't get what I paid for, right? And I don't get the performance, and I get a system that's maybe choked. And by choked, I mean it's not getting the proper airflows. Therefore, the compressors run at higher amperage, and the power bill is higher than it should be, and the longevity of the piece of equipment is shorter than it should be. So there's so much other, and I think that's what Alex was saying last episode. There's so much other stuff that goes into, properly selecting and sizing equipment than just saying, oh, 48,000 BTUs, 48,000 BTUs, we're all good, right? Certainly, there's more to it, and I think maybe we're starting to delve into why don't guys do it, right? We're challenging them to be better. Not we personally, but the the people that are writing our laws and the people that are interpreting and understanding how this equipment works are asking these HVAC contractors for better installations, for better performance. The equipment manufacturers certainly want a better installation. They don't want compressor failures. They don't want component failures. They don't want short life pieces of equipment, right? So from our perspective, we're in support of the things that help us get a better installation, help us get a better running piece of equipment.
Right, right. And obviously we're coming to it from the manufacturer's perspective. And I think a lot of times we talk about our machinery so much that, yes, that obviously is extremely important, but the application and the installation is very, very, very key to making it run right. And I think, to your point, some of that is starting to come back to light in the trade, that guys are realizing how important duct systems are for a ducted system. And so there's two different challenges that we're experiencing is, new construction, I would say duct systems, obviously the opportunity is to fix it right the first time. Retrofit guys have a lot bigger challenge sometimes, because sometimes you got what you got, right? You're doing a retrofit on this job, and yeah, you got to fix that duct flow or that duct work and that airflow. You've got to get the static pressure to within range. So you do what you can do, but you are sometimes limited to that. Sometimes you're not. And sometimes budget limits it from the homeowner. What are they willing to pay you to do? You may need to revamp the entire duct system because it may have been a very poor install and poorly designed and sized duct system. Maybe you can do some modification and pull out, say, some of the flex duct and go back in with like a large trunk line or something like that and get the airflow the way you need to do. Or maybe you can increase the size of the return air or add a second return. Seems to me, and maybe it's just from the homes that I've been in and experienced, but to me, the return was most often the bigger issue than the supply. Not always, of course, but I ran into undersized returns more commonly than I did anything else. Although that's not to say that an oversized duct system hasn't bit me in the butt one time in my career, but I learned from that one.
I think we spoke about that on a prior podcast.
We did. It cost me a lot of money.
Yeah. And you know what? That's when guys learn the best, right? When it hits them in the wallet, that's when folks learn. All right.
Yep.
So, and if I'm a contractor and I lose money on a job, I want to make sure that I don't make that mistake again. So it's, kind of fire by whatever that saying is, right? So
trial by fire.
Yeah, that's it. Trial by fire. It's getting late in the day here. There was a wealth of stuff that came out of that prior episode. And I could have sat for 4 more hours and picked his brain, right? Because certainly he's been around our industry, in our industry, and then, like you said, he made it very clear. Nope, not from the field side, but from the other side, from the side that says, this is how we do it. This is why we need to do it this way. This is what happens if we don't do it. Please listen to me or some of my peers, right? I just think there's sometimes there's a stubbornness and a unwillingness from an HVAC contractor to attempt to do something different than it has been in the past. So whatever we can do to help that, ease that burden, be good for us.
Right. And I don't want to say I necessarily learned it, but it certainly brought back to my mind the importance of understanding the why. Do we just go out and learn how to run some software to do some load calcs? Or do we need to understand what's going on behind that load calculation? Why is it giving me the numbers that it's giving me? If this one category seems awfully high or awfully low, understanding why that changes it. Why does an attic house have a higher ceiling load than a roof ceiling combination? Understanding, hey, you've got 140, 120 degree attic pushing down on that ceiling versus a roof ceiling combination where the outdoor temperature is only whatever, 90, 95 degrees maybe in the summer. Well, to me, that just, the moment that I recognized that, it just kind of, it woke me up a little bit, because my assumption before I really learned and understood would be that, if there's that gap, that would be better, right? I've got some protection against the sun instead of that roof ceiling where the sun's just baking down on that roof. When I really started to dig into the whys behind it, now I understood a little bit, and I went, oh, that's actually a higher load than that way. And so understanding the whys was important to me, and that made me really want to get deeper into the building science when I was in the field. And I attended a few building science courses and things where I could learn from them. And that really helped me as a designer when I'm looking at homes and I'm working with builders and I'm working with the homeowners, just going, hey, let's understand where the driving force is on your home. And we kind of pointed to this in the last episode, bringing the home to the system. I think in the retrofit and the change out scenario is a wonderful time, because if you take the time and you do a load calculation with the homeowner and you say, hey, you've got whatever, your home is a 3-ton home currently, and you have a 3-ton machine. Great. It's sized properly. That's wonderful. We can go back with that. But if you look right here in this section of the load calculation, we see that you have an awful lot of load coming in from, let's say, the windows, and you've got some western facing windows, and you talked about maybe wanting to do some upgrades to your home. If you just change those 3 windows on the west side and that one on the east side, let me show you what that would do. And so that's where using that software can be powerful, because you can illustrate those changes and go, hey, we have the opportunity here to put in a smaller air conditioner. It'll cost you less to buy. It'll have a lower power utility bill because we're running a smaller machine, right? But you've done the things to the home to bring the load down to the point where it matches that machine. And so you've made that investment on both sides. And that really is where we can go to start making homes better and systems better for our customers.
Well, I mean, there's a whole electrification process going on in our country, and that process includes envelope improvement, right? And if we're the grid's taxed, but our LG inverter driven system certainly help that phenomenon, right? But helping the envelope, changing the envelope, and requiring smaller systems from us compounds even more the impact on electrical savings and electrical usage, right? We use less as a general rule anyway as an inverter driven product. Now, if I can improve the envelope and make a smaller system, I use less again, right? There's value there for sure as we move across the country. And, I see it. I looked at a load count this morning for this guy, and it was 8,400 BTUs of heat. Okay. 427 square foot cabins in 10,000 feet somewhere in Colorado. It's building like 50 of these cabins, right? He has for us, an LMU 24 in it with two 15,000 BTU heads. So 24,000 BTUs packed into this little house. And, my question was why? And he goes, well, if you do negative 13 and you had all this charts and all this stuff, and I'm like, look, man, it's grossly oversized. It's never going to run long enough to satisfy an air conditioning mode or to be of any value. And the heat's grossly oversized, and you got a gas heater coming in it anyway. So why are we doing this, right? So I talked him off a cliff, showed him the performance through our capacity charts, right? At negative 13 degrees Fahrenheit. We were making 9,000+ BTUs with a 12,000 BTU machine at max capacity. All right. So he already had the weather bin data for me, not AHRI data. He already knew that in the last 10 years, it only got negative 13 in that town in Colorado 10 times. Right. So he knew already. And it happened in the middle of the night for 20 or 30 minutes. Right. That was, so when you have the opportunity to sit with somebody that's designing and building, and you can have that kind of conversation versus just getting in the truck and driving out and pulling up to the driveway and going, here's a 3-ton, right? we get better as a trade. We get better as an industry. Consumers benefit from that level of involvement. So that's where I want to see our trade go to. Sit down and have these conversations. Stop just accepting what was is what should be. And I think when we continue down that path, we get better. And better is better. Stealing is
Yeah.
life.
Yeah. And what we've done and we still do is, we guess and then we pad it a little bit because we're scared that our guess might be wrong. And so then we end up way, way, way wrong guessing. You've got to know your numbers, right? You've got to know what your loads are. You've got to do your load calcs at the right design temperatures. Manual J already has wiggle room built into it.
Right.
I've seen guys that are in markets and they're designing 10, 12 degrees colder than they actually should be based on the ACCA numbers. And when I ask them why, well, once in a while it gets that cold here. Well, to your point, it's once in a blue moon and it's not for very long and it's in the middle of the night. And that's not how we design a system. The same way we can get to 105 in Georgia. That's not where we design our systems for. There are times where the system will still work. And I don't want to say it like that. The system will absolutely still work and work properly, but that it may not maintain those interior temperatures that we want. And that's actually part of the Manual J textbook. It talks about there may be times where the interior temperature drifts a little bit, but that's still better than having an oversized system because basically an oversized system is so much worse than that. So we've got to start doing proper load calculations, and then we've got to use the actual data, right? So we've got to go into, and you mentioned it, the performance tables. So we have 2 performance tables for all of our equipment. We have a rated capacity, which is kind of what we design with, and that's what we use for Manual S and all that. But it's also important to know the maximum output. And we have that both for heating and for cooling. So to your point, that you have the ability in that machine at negative 13 degrees to produce 9,000, whatever you said, BTUs. And so what that machine is actually capable of. So it's important that guys know where to go. It's located in our engineering manuals, which we make public for all of our equipment. And it's also part of our LATS program for our system design software that we have. And we encourage all of our guys to build their systems in LATS, and that way they can see what is the output in their weather area. Because I don't need to know what heating capabilities that machine has at negative 13 because I don't live in that environment. I live in Georgia, so I need to know what that machine is capable of doing at my design temperature. Or you in Florida, where y'all don't care about heat at all in Florida, basically, but you need to know what can that thing do in cooling. Well, you get cold twice a year, right?
Both times.
Both times, right? But it's important to know the numbers and to just quit using the number on the box. The number on the box is from a theoretical laboratory environment, but we need to know what is it actually going to do in your environment where that home is located.
Yeah, I agree. So, well, certainly like I said, the last episode brought a lot of stuff that I knew that probably forgot.
Right.
But certainly brought awareness to the fact that properly sizing, properly selecting could mean more than just running the numbers, because it could be other variables and other values that, like you said, you jumped off the cliff and you ran a load calc and it didn't work and you blamed the load calc, right? When it was the fact that the duct system's grossly undersized, or the fact that the house is leaking like a sieve, right? Yep. So don't panic, all right? Better is better, to use his phrase, right? Let's continue down the path of getting better, and let's make better systems for folks.
Yeah, that's what we want to do. We want to have some fun and cut up a little bit on here, but we want guys to learn as they watch these episodes or listen to these episodes. We have a lot of information. We have a lot of data, performance data, and we're happy to help guys. Reach out to your local LG distributor or your local area sales manager, and they can help you find this information if you don't already know where it's at. But we make it all public. We want our contractors to use them, and very important to me in my role with LG is developing contractors, and that's a piece of it is educating the contractors and helping them know even better and easier how to find the information, how to use that information, how to apply that information so that they can begin doing things better, And I know we've robbed Alex of about 100 quotes during this episode here, but he made a point that just because your homeowner's happy, that's not a very good goalpost. Just because they're not complaining doesn't mean you really did a good job. Let's be the best. That's always been my thing is I want to know more than anybody else. I want to do better than anybody else, or at minimum the best that I can, acknowledging that there's always going to be smarter and better people out there. And I'm grateful for that because that means I can learn and continue to push myself even more. But I never really wanted to be the average contractor. I didn't want my systems to be just as good as, the company down the street. I wanted my customers to, when they got a new system, to go, wow, there's something different. Or maybe they had a great system before and we just had to go back and give them another wow experience. But so often we were able to go in and find all of the issues, find that the return was the wrong size or the machine was the wrong size or both, help them look at their home and look at improvements that we can make. Weatherization, to your point, has really, really come up in, I don't want to say importance because it's always been important, but it's definitely coming to the surface as far as some incentives that are out there and some focus that's on it, tightening up these envelopes so that we're not just air conditioning the outside. Like my dad used to say, shut the door, I don't need I don't need to air condition the outside. Right. So, but that's what we're doing with these leaky homes, is we're air conditioning the outside more than we realize. So bringing the home to the system and then bringing the right system to the home, when we can do both of those things, we can be better.
Super. Well, I think pretty well covers it for me today. Let's have a little fun. Want to have some fun?
I always want to have fun. What you got?
All right. Let's do some HVAC rules of thumb. All right.
All right.
So, all right. Let's start with the first one. What's a ton?
Oh, it's 12,000 BTUs, right? Always ish.
Yeah. Right. So a ton, right? Let's see. What is what do you say the V is in HVAC?
Well, that's ventilation, right?
What do we do with ventilation?
I don't know. We pump some air in, pump some air out. We do something with it. No, but it's important, right? I know you're kidding,
important.
But
no, it's
understanding
important, right?
ERVs, HRVs, dehumidification, airflow throughout the home, especially with these tighter homes, you may not be able to distribute if you have a large home. We'll throw a kind of a ridiculous example out there, but you have a 3,000 square foot home and it's got a 2-ton load. So you're talking 700 to 800 CFM, trying to distribute that among a 3,000 square foot home, nearly impossible with the typical duct system. Understanding air movement, air share devices, zoning that load out to different areas of the home so that we can go in this pocket and do the work over here and go over here and do the work there. But also some of these air share fans that are being made by many different manufacturers. We don't have one, but there's several great ones on the market. But that's what's coming, right? So being able to move that air, I've seen apartments that are being done with one wall mount system and they're using air share fans to push the air in and out of the different rooms. And it's being wildly successful. It's bringing down the cost of, it's bringing down the cost of everything. Yeah. Yep.
So that's good stuff. All right. What's a BTU?
It's a British thermal unit.
That doesn't mean anything to me. Right. No.
So why are there 12,000 BTUs in a ton, Terry?
That's a great question. A ton's 2,000 pounds.
So it takes 12,000 BTUs to change the temperature of 12,000 of 1 ton of ice by 1 degree.
Is that where it came from?
That's where it came from.
That's amazing. So 12,000 BTUs equals a ton of ice.
To change the temperature to bring ice from the state of ice to liquid, to change it 1 degree, takes 12,000 BTUs.
That's all I got for today, Phillip. I know we wrapped this up on the back of another episode, so I appreciate your time today, and as always, and appreciate your candor and your knowledge of our industry.
Terry, likewise, I've learned lots from you over the years. I look forward to learning lots more. I love hanging out and doing these podcasts with you. Hopefully everybody else enjoys it a little bit as much as we do, and learns a little bit every time they show up. So everybody, thank you for being with us. This has been another episode of the LG Procast.
Super. Again, I'm Terry Frisenda signing off from the LG Procast. We'll be back to you with the next episode soon.